Today we're diving into why understanding car electronics is crucial if you plan on fixing them yourself. Let's face it, electrical issues can be a real pain in the neck, but they don't have to be a mystery. Once you understand the basics, you'll be able to diagnose and fix many common problems without having to take your car to a mechanic. We're going to cover a bunch of common car electronic issues, from dead batteries to those pesky check engine lights. I'll give you the know-how to tackle these problems head-on and save some serious cash in the process. So grab your tools and let's get started. Alright, let's start with one of the most common car problems, a dead battery. You know the drill, you go to start your car and nothing happens, just that dreaded clicking sound. The most likely culprit is a dead battery, especially if it's old and hasn't been replaced in a while. The first thing you want to do is check the battery's voltage with a multimeter. A fully charged battery should read around 12.6 volts. Anything lower than 12 volts, and you're looking at a weak battery that needs charging or replacing. Now if you need to replace the battery, it's a pretty straightforward process. Disconnect the negative cable first, then the positive. Always remember to remove the negative cable first to avoid any accidental shorts. Once the old battery is out, clean the battery terminals with a wire brush and some baking soda to remove any corrosion. Trust me, this makes a big difference in ensuring a good connection. Now install the new battery, making sure to connect the positive cable first this time, followed by the negative. Tighten everything down, and you're good to go. If your car starts right up, you've successfully conquered the dead battery. Let's talk about the alternator, the unsung hero of your car's electrical system. This little guy is responsible for keeping your battery charged and powering all the electrical components while you're driving. A failing alternator can lead to a whole bunch of problems, including a dead battery, dim headlights, and even stalling. So how can you tell if your alternator is on its way out? One telltale sign is a whining noise coming from the alternator itself. This usually means the bearings are going bad and need to be replaced. Another way to check is by looking at your headlights while the engine is running. If they dim significantly when you turn on accessories like the radio or air conditioning, that's a good indication your alternator is struggling to keep up. You can also use a multimeter to test the alternator's output. With the engine running, connect the multimeter to the battery terminals. A healthy alternator should be putting out around 13.5 to 14.5 volts. Anything lower or higher than that range, and you might have a problem. If your alternator is indeed faulty, you'll need to replace it. It's not a difficult job, but it does involve some mechanical work. You'll need to locate and disconnect the battery, remove the alternator belt, and then unbolt the alternator itself. Installation is the reverse of removal, and remember to properly tension the alternator belt. Blown fuses are another common electrical gremlin that can bring your car to its knees. These little guys are like safety valves for your car's electrical system. If there's a sudden surge of electricity, the fuse blows, protecting more expensive components from damage. The good news is that blown fuses are usually easy and inexpensive to fix. The challenge is often figuring out which fuse controls what. That's where your car's owner's manual comes in handy. It should have a fuse box diagram that shows you exactly which fuse corresponds to which component. To check if a fuse is blown, simply look at it. A blown fuse will have a broken wire inside. If you're not sure, you can also use a multimeter to test for continuity. Set the multimeter to continuity mode and touch the probes to each end of the fuse. If the multimeter beeps, the fuse is good. If it doesn't, the fuse is blown. To replace a blown fuse, simply use a fuse puller or a pair of needle nose pliers to remove the old fuse and insert a new one with the same amperage rating. Make sure the new fuse is seated properly in the fuse box and you're good to go. Now let's move on to the starter motor, the muscle behind getting your engine going. When you turn the key, the starter motor engages with the engine's flywheel, cranking it over and starting the combustion process. A failing starter motor can manifest itself in a few ways. You might hear a clicking sound when you turn the key, but the engine doesn't crank. Or, you might hear a grinding noise as the starter struggles to engage with the flywheel. If you suspect your starter motor is on its way out, there are a few things you can try. First, make sure the battery connections are clean and tight. A weak battery can sometimes mimic a bad starter. If the battery is good, you can try giving the starter motor a few taps with a hammer. This can sometimes free up a sticking solenoid and get the starter working again. However, this is only a temporary fix. If all else fails, you'll need to replace the starter motor. This is a more involved repair that usually requires getting under the car. You'll need to locate the starter, disconnect the battery, remove the electrical connections and mounting bolts, and then carefully lower the starter out of the car. Installation is the reverse of removal. Let's face it, driving at night with dim or flickering headlights is not only annoying but also dangerous. Several things can cause this issue, from a dying battery to a bad alternator to even a simple wiring problem. If your headlights are dim, the first thing you want to check is the battery voltage. A weak battery can definitely cause dim headlights, especially when the engine is off. If the battery checks out, move on to the alternator. Remember, the alternator is responsible for keeping the battery charged and powering the electrical system while the engine is running. A failing alternator can lead to all sorts of electrical gremlins, including dim headlights. Another common culprit is a bad ground connection. The ground wire is what completes the electrical circuit, allowing electricity to flow back to the battery. Over time, ground connections can become corroded or loose, leading to all sorts of strange electrical problems. If you're experiencing flickering headlights, the problem could be a loose bulb, a faulty headlight relay, or even a problem with the headlight switch itself. Start by checking the bulbs, and make sure they're securely seated in their sockets. If the bulbs look good, move on to the headlight relay, which is usually located in the fuse box under the hood. You can try swapping the headlight relay with another relay of the same type, to see if that solves the problem. Power windows and door locks are one of those conveniences that we often take for granted, until they stop working, that is. Fortunately, most power window and door lock problems are relatively easy to diagnose and fix. One of the most common issues is a blown fuse or a faulty window or door lock switch. Check the fuse box for any blown fuses related to the windows or door locks. If you find a blown fuse, replace it with a new one of the same amperage. If the fuses are good, the problem could be a faulty switch. You can test the switch with a multimeter to see if it's sending power to the motor. Another common culprit is a bad window regulator or door lock actuator. The window regulator is the mechanism that raises and lowers the window, while the door lock actuator is the motor that locks and unlocks the door. If you hear a clicking noise when you try to operate the window or door lock, but nothing happens, it's likely that the regulator or actuator is faulty. Finally, if you're experiencing intermittent problems with your power windows or door locks, the problem could be a loose or corroded wiring connection. Check all the wiring connections to the window motors, door lock actuators and switches, and clean or tighten any loose or corroded connections. The check engine light has to be one of the most dreaded sights for any car owner. It could mean anything from a loose gas cap to a serious engine problem. But don't panic just yet. With a little knowledge and a handy tool called an OBD2 scanner, you can decipher those cryptic codes and get to the bottom of the issue. The first thing you need to do is connect your OBD2 scanner to your car's OBD2 port, which is usually located under the dashboard on the driver's side. Once connected, the scanner will read the trouble codes stored in your car's computer. Now here's where it gets interesting. Each trouble code corresponds to a specific problem with your car. For example, a code P0420 indicates a problem with the catalytic converter system, while a code P0300 indicates a random misfire. Once you have the trouble code, you can use a code reader or look it up online to find out what it means and how to fix it. In some cases, the fix might be as simple as tightening your gas cap or replacing a faulty sensor. In other cases, it might require a more involved repair. Have you ever come out to your car in the morning to find your battery dead, even though you're sure you didn't leave anything on? If so, you might be a victim of parasitic battery drain. Parasitic battery drain occurs when a component in your car continues to draw power from the battery even when the ignition is turned off. This can be caused by a faulty component such as a clock, radio, or interior light, or by a wiring problem. To diagnose a parasitic battery drain, you'll need a multimeter and a little patience. Start by disconnecting the negative battery cable and connecting the multimeter in series between the negative battery terminal and the negative battery cable. This will allow you to measure the current draw with the ignition off. A healthy car should have a parasitic draw of less than 50 milliamps. If you're seeing a draw of more than that, start pulling fuses one at a time while watching the multimeter. When the current draw drops significantly, you've found the circuit with the parasitic draw. From there, you can start narrowing down the culprit by checking the components on that circuit. It could be a faulty relay, a stuck switch, or even a bad ground connection. Once you've identified the culprit, you can replace the faulty component, or repair the wiring problem. Intermittent electrical problems can be some of the most frustrating problems to diagnose and fix. These are the problems that come and go as they please, making it difficult to pinpoint the cause. One of the most helpful things you can do when dealing with an intermittent electrical problem is to keep a detailed log of when the problem occurs, what the symptoms are, and what you were doing when the problem occurred. This information can be invaluable in helping you narrow down the potential causes. Another helpful tip is to pay attention to any changes in the environment or your driving habits that seem to coincide with the problem. For example, does the problem only occur when it's raining or when you hit a bump? Does it only happen when the engine is cold or hot? Once you have a better understanding of when and how the problem occurs, you can start testing the suspect circuits and components. This might involve wiggling wires, tapping on relays, or manipulating switches while watching for the problem to occur. If you're still struggling to find the culprit, you might consider taking your car to a qualified mechanic with experience in diagnosing intermittent electrical problems. They have the tools and expertise to track down even the most elusive electrical gremlins. So there you have it, folks. Understanding car electronics is essential for any DIY mechanic. Make sure to subscribe for more car repair tips and tricks. Thanks for watching, and I'll see you in the next video.